Hi everyone. Today I am going to talk about high resolution change detection. Can any of you define change detection?
No.
No? Okay, when I am talking about change detection, I am mainly talking about the imageries here because changes can be in other things also. So I am talking about the remote sensing images, and then our main focus will be on machine learning techniques. So talking about the techniques for machine learning, so there are mainly three techniques. So first one is known as clustering, and second one is known as classification, and third one is the regression. So let me first try to explain what is clustering. So let me give you an example. For instance, you have three cards. I think everyone play cards, and then let's suppose that first card has an image of a cat. Let's suppose that second card has image of a dog, and let's suppose that third card has image of a bird. So how would you group those? So some might group them into categories in different classes. First would group dog is class 1, 2 is category for cat, and the third one for birds. So this could be one way of classifying. But when we say next people to group those, some of you might group those into just two categories. For instance, you might group one of the category is two-legged animal, and then another is four-legged. So you might only have two classifications, and then some of you might group them in many different ways because everyone has their own way of grouping. Then who do you think is correct? Any idea? Who is correct? No? So I would say that everyone is correct because it's just a way of grouping. That is known as clustering. So we can cluster and group them in any way that we want, but everyone is correct in this case. And the next one is the classification. So when computer tries to group the various objects into various classes, so it looks for the various features. It especially looks for the unique distinguishing characteristics in the objects. For instance, it searches for its eyes, nose, mouth, and other unique characteristics that are completely different. And then the model will be able to tell that this is cat, this is dog, and then this is bird. And by that way, it will be able to classify the objects. The interesting thing is that it is not only able to classify the objects that we assign, like dog, cat, or birds. So it might be able to tell that this is a horse because it looks at the patterns. And by understanding the patterns, it will be able to tell the objects that we did not define. And then the third category is the regression. So in regression, we have various points. So there might be different points, and then we try to connect these points in a single line. And then we can look at how the changes in weight or shape of the object could relate with the size of the object. And then we can know that this object is of specific size. And these are all about the techniques of machine learning. Now let me talk about some of the challenges that we might encounter when we deal with machine learning. Firstly, the main challenge is working with data because the size of the data might be too large, and then we might need a computer which needs to have a very very powerful computational abilities, and that is the major challenge. And next challenge I would like to talk is radiometric error. So this might be the error that we face, because sometimes the brightness or intensity level of the images might not be the same, and then we need to normalize them so that they are same, so it is easier to compare. And then there is another type of error that you might encounter, which is the geometric error. This is related with the aligning of the images. So sometimes when we take images from different angles, they might look different, and we might think that there is change in the object, but in fact there is no change, because it is just the view angle. Sometimes we take camera photos with our cameras when the objects will seem like tilted, and then sometimes the position will be different, and then they look different, but it's not the change. So we need to correct for that. And then let me talk about some future opportunities and what can be done. So we could do some real-time change detection in the images. Most of the research focus only on seeing the changes in the past images, but if we can do something more than that, that would be really great. And the next thing we can do is that we can predict, like this might be the change based on the learnings from the computers. Think what would happen if we have to do it all manually. We would need a lot of time, but since we are using machines and computers, they are able to do that in a relatively shorter period of time, and it is also effective in terms of cost and time. And then there are different machine learning algorithms that I would like to discuss some of them. The first one is the CNN, or convolutional neural network. So this is the neural network that helps us to identify in the images, like this is the image of a building, this is cat, this is dog. So it helps to better distinguish the objects. And the next one I would like to talk is the FCN, or fully convolutional neural network. So what this does is that it segments the images. So if we have the image and if we have various pixels, so this is pixel, so it will try to classify each pixel into various objects. It might classify this as object 1 and then give classification to other pixels also, so it will classify each pixels. And there is another type of neural network which is known as generative adversarial neural network. So mainly there are two types of it. The first one is the generator, and the second one is determinator, and then there is recurrent neural network. So this is the type of neural network in which the computer learns from the previous examples. So it will know that this object is cat, this is dog, and then based on that previous finding, it will try to identifying the other imageries. And then there is more advanced neural network which is known as UNet. So UNet is also based on semantic segmentation of the images, similar to FCN, but it looks at more detailed and more zoomed in view of the image. So in summary, today we discussed about the various change detection in the imageries, and we talked about the various techniques for machine learning. We looked at radiometric and geometric corrections, and then we also deal with some future opportunities and deal with some algorithms. I think today's session was really informative and you learned a lot. Thank you. Any questions, suggestions? I welcome.
So this high resolution change detections will be used in robots and stuff. Where will this technology be used?
Oh, yeah, that's a very good question. So this technology can be used in robot stuff also, and then it can be used in multiple other applications, such as in agricultural change detection in the imageries to predict the objects. So it is not only limited to the robot. So it can be useful for that also. So this concept is also used in automatic driving of the vehicles. So they design the technologies accordingly, and then we can use it for change detection in the urban areas. So the scope is large. Yeah.
Okay.
I hope this answers your question.
Yeah.
So all the algorithm, do we use that in at once, or we can choose whatever we want to choose?
Yeah, that is a really good question. So, we cannot say that this algorithm is best for this purpose. So we need to test it.
Individually?
Yeah, we need to first use CNN and then come up with the findings and results. Then we can use FCN, GAN, and then from the findings you can decide that this is the best one. So after you get the results, you can compare that in the softwares like ArcGIS Pro or QGIS, and then you can look at the results on the map, and then you can decide yourself like how accurate those predictions are made by looking at the images, and then you will know that this one is the best algorithm. So I think this answered your question.
Okay, good.